A complex fraction is whenever you have a fraction within a fraction. So either a fraction in the numerator or a fraction in the denominator. In this case, in this first example, we have both. We have a fraction in the numerator and we have two fractions in the denominator. So your first step for simplifying a complex fraction is we only want there to be one fraction in the numerator, and in this case there is only one fraction in the numerator, and we want only one fraction in the denominator. But in this case we have two fractions in the denominator. So before we can simplify this complex fraction, we first have to simplify the denominator. So to simplify this denominator, we need to get a common denominator within the denominator so that we can combine those two terms together. So ignore the numerator for a second here. Ignore what's in red. We need to add these two fractions before we can get started. They do not have a common denominator. So to get a common denominator, we are going to need to multiply this first fraction by x over x, because the second fraction had an x in the denominator. And we're going to need to multiply the second fraction by x plus 2, because the first fraction had an x plus 2 in the denominator. So we're going to combine these together. So we have 1x over x times x plus 2. That's what our first one's going to become. I do not need to multiply out the denominator, but it is helpful to multiply out the numerator. So our new numerator on the right side is 3x plus 6. And now that we have a common denominator, I can combine like terms in the numerator over that common denominator. All right, so this is my new denominator. I should write it in green because I started in green. So I can factor that numerator. I can factor out a 2, so I'm going to go ahead and do that. My denominator is already factored. So when we're talking about the original problem, I just simplified the denominator so that it was now written just as one big fraction instead of two fractions connected by a plus sign. My numerator, I did not need to do that with. It was already written as one big fraction, so let me rewrite that. So first thing is to simplify the numerator or the denominator if that's what needs to happen. We did that step. Now we need to simplify the complex fraction altogether. So remember, fractions are just fancy division problems. So what this says, if I were to write this out, it says 5 over x plus 2 divided by 2 times 2x plus 3 over x times x plus 2. So I'm just rewriting the division problem horizontally instead of vertically. And that's what it says. Well, when we divide with fractions, what we're really doing is we are multiplying by the reciprocal instead. So, or maybe you've heard keep it, where we keep the first fraction, we change it, we change division to multiplication, and then we flip it. Keep it, change it, flip it. Keep the first fraction, change division to multiplication, and flip the second fraction. So it's the reciprocal, multiplying by the reciprocal. And then it becomes a multiplication problem where we can check to see if anything cancels out. So I have an x plus 2 in the denominator, an x plus 2 in the numerator. Those two things cancel. So now what's left is a 5x in the numerator, a 2 and a 2x plus 3 in the denominator. Nothing else cancels out. That is my final answer. Let's look at this example. What's different about this example is we are going to have to simplify the numerator and we're going to have to simplify the denominator because our numerator is written as two separate fractions. It's two terms. We need to combine it to make it one term. And so is our denominator. But these are going to be a little bit easier to simplify. So with the numerator, I have x over 5 minus x over 10. It's not a common denominator, but I can get a common denominator easily by multiplying by 2 over 2 to the first fraction, When I do that, I get 2x over 10 minus x over 10. And when I combine those numerators together, I get x over 10. So my numerator simplifies to just x over 10. I'm going to do the same thing in my denominator. Right now I have x over 3 minus 5 over 6. There's not a common denominator, but I can get one easily by multiplying by 2 over 2 to the first fraction. When I do that, I get 2x over 6 minus 5 over 6. Now that we have a common denominator of 6, I can combine the numerators together. They are not like terms, so it stays 2x minus 5. And now the original denominator is written as one fraction. I went from green to blue. Whoops. But now we have a setup where we have x over 10. I'll write it horizontally again so you can see what's happening. Divided by 2x minus 5 divided by 6. So I have a division problems within a division problem. It's easier to rewrite this as a multiplication problem. So keep it, change it, flip it. None of those can be factored. So we just check to see, does anything cancel out? And nothing cancels out directly, but 6 over 10 can be reduced to 3 over 5. So we have 3x, it's a 3, over 5 times 2x minus 5. And from here, nothing else cancels. So that is our final answer. Let's do one more problem. So this one, my numerator is already written as one fraction. We're good there. But in our denominator, we need to add those two fractions together before the denominator is simplified. So let me rewrite this. I have 2 over x minus 1 plus 1 over x plus 2. To get a common denominator, I'm going to need to multiply this by x plus 2 over x plus 2. And this fraction needs an x minus 1 in the denominator. So when I multiply those numerators, when I distribute, I get a 2x plus 4. And I get a 1x minus 1 all over our now common denominator of x plus 2 and x minus 1. Combining like terms, I have 3x plus 3 over x plus 2 and x minus 1. And I ran out of room, so I'm not going to simplify that yet. That I now have 3 over x plus 2 as my numerator divided by 3x plus 3 over x plus 2, x minus 1 in my denominator. So I'm going to keep the first fraction, change the division problem to a multiplication problem, flip the second set. Now I'm going to go ahead and factor this 3x plus 3. I can factor out a GCF. I'm going to go ahead and do that. And now we're going to check to see what all cancels out. So this x plus 2 cancels out with that x plus 2. This 3 cancels out with that 3. An x minus 1 does not cancel out with an x plus 1, so that is our final answer.